Any doubts both of you have in these topics which I taught in the last class?
No, ma'am.
I think I'm not able to hear you.
No, ma'am.
Wait, beta. It's not because of you. I think. Can you speak one more time?
No, ma'am.
I think something is wrong. Pranav, can you speak now once?
Ma'am?
I'm not able to hear. Wait, one last time. I will try just a second. I think now I will be able to hear.
Ma'am, can you hear me?
Now, yes, I can. I don't know what happened with my device. Okay. So I was asking if anyone amongst you have any doubt in these terms which we had studied in the last class.
No, ma'am.
What about others? Sampath, Akshra, Jitendra,
No, ma'am.
No, ma'am.
Akshra, Harshit.
Yeah, ma'am.
Okay. Any doubts I'm asking
No,
if you
ma'am.
have in these terms? Okay. Now I would like to ask the meaning of these terms from you so that we can begin further. First of all, who will tell me what is meant by melting? Yes, Pranav, go ahead and tell.
Solid to liquid, ma'am.
So process in which the solid gets converted into liquids.
Liquid.
There. Akshra, can you tell me what is vaporization? Akshara. Harshit, can you tell me what is vaporization?
Ma'am, any liquid turning into gaseous state on heating is called vaporization or boiling.
So it is basically the process of conversion of liquid to gas. Next, Jitendra, can you tell me what is meant by freezing or solidification?
Converse gas converting into liquid upon cooling.
Very good. Rohit, Rohit, Sampath.
Yes, ma'am.
Sampath, can you tell me what is sublimation?
Ma'am, sublimation, it is the process in which the gas, solid directly gets converted into gas without changing into liquid.
Good. Okay, Rohit, now can you unmute yourself?
Yes, ma'am.
And why is your video turned off? Keep
Ma'am, I'll
your
just
video
turn it
turned
on in
on.
a second.
Okay. Rohit, can you give me any two example of sublimation or deposition?
Ma'am, O2 and CO2?
O2 is not the example of sublimation. Carbon dioxide is solid carbon dioxide and
Ma'am, ma'am, the second one I don't know. I know that carbon dioxide is.
okay. Akshara, can you? Akshara,
Ma'am, which one?
can you give me any other example apart from solid carbon dioxide for sublimation?
Dry ice.
Dry ice is solid carbon dioxide. Any other example?
Can I?
Hmm?
Ma'am, it's camphor.
It's camphor. Good. Okay. Akshara and Sampath, keep your video turned on. Okay, children. So in the last class, I gave you the definitions of all these terms which we come across in our everyday life also. Now I will give you the examples which you can relate in your everyday life. Then further we will move ahead. So children, if we talk about melting, so you are already aware that if we take ice out of refrigerator, out of freezer actually, and keep it aside, what will happen? It will convert into liquid water.
Yes, ma'am.
And what do we say? That the ice has melted. So the most common example of this conversion of solid to liquid is the conversion of ice to liquid water. Then next we have vaporization or boiling. If we take water and keep it for heating, what happens? It starts to convert into the water vapor, which is very clearly visible
ma'am.
to us also. So then we say that what is happening? The water is boiling. Then the third one is condensation. First, I'll write the example of the first one. Today it's 10-4. So the example is ice to water. Then for boiling, it's water to water vapors. Then we have condensation. Children, you must have observed that whenever we take a bath, whenever we take a hot shower, in that case, the mirror, if at all there is any mirror in the washroom, it has some small water droplets present on it. So what that actually is due to, that is because of condensation only, because what happens in the condensation, the gases which are present in the atmosphere, they cool down on the surface of the mirror. So the conversion of water vapors back to water. And what about solidification? Solidification, name itself is suggesting that the liquid is getting converted into the solid state. And what is the best example which you come across in your everyday life? You take the
Ma'am,
normal
water to ice.
tap, yes, and it gets converted into ice. Now, if we talk about sublimation, which you must have surely observed in your everyday life, is camphor. First of all, camphor is basically kapoor in Hindi. So when we burn camphor, the white solid particles, they get directly converted into the gaseous state. Apart from that, in your everyday life, you must have come across the naphthalene balls. These are the moth balls which we keep in our clothes to make sure that the moths do not attract the clothes and they do not damage the clothes, and they directly get converted from solid to liquid. Our clothes never get wet if we keep the naphthalene balls in, right? And deposition, it is always the reverse of it, but in that we have to collect the vapors and then cool them. So we do not observe it in our everyday life as such, but then any example of sublimation is the example of deposition. Clear everyone? Any doubts still here? Okay, children. Now let us discuss a few more terms which are very important and then we will move forward. So the first term which we have to discuss now is the melting point. Now, what is melting point? It is the temperature at which a solid melts to become liquid at atmospheric pressure. Means whatever is the pressure of the atmosphere, at that pressure, whatever temperature is required to convert the solid into the liquid is called its melting point. So basically, melting point is the temperature which help us to know when the solid will get converted into the liquid state. Clear? So what is the melting point of ice? Does anyone know?
It's
Ma'am, room
above, is it
temperature.
above 0 degrees?
No, it is not above 0 degrees Celsius. It is 0 degrees Celsius. Melting point of ice is 0 degrees Celsius. Clear everyone? Any doubts still here? Okay, children.
Okay, ma'am.
So let us move to the next term. Then we have some other things also to discuss. I will discuss those later. First, we will complete the another term, which is the temperature. So the next is the freezing point. Now, what is freezing point? Again, it is the temperature at which there are very interesting things which are related to these processes, which we will discuss after discussing these definitions. The liquid freezes to become solid at atmospheric pressure. This temperature is known as freezing point. Clear? Now I'm going to tell you a very interesting point. It is that both the melting point and the freezing point are the same temperatures. So freezing point of water here will be at what temperature the water will start to freeze at 0
0
degrees
degrees.
only. Fine. So do remember this. Then we have another term which is boiling point. The temperature at which a liquid starts boiling at the atmospheric pressure. So basically, the temperature at which the liquid get converted into the gaseous state, that is known as the boiling point, is called its boiling point. Okay, now what is the boiling point of water? Who can tell?
Ma'am, it's 100 degrees Celsius.
Very good. So the boiling point of water is 100 degrees Celsius. Any doubts still here, anyone? Yes, that is all for these three terms. Then we have some more few terms which are related. Acha children, abhi tak whatever we have studied till now, these are all the effects of change of temperature. We are still to discuss the change of pressure, the effect of change of pressure. Now you will be very surprised to know one very important thing. Like if we talk about the conversion of the ice to water, what happens is, I'll draw the setup and then I'll explain you. It's very simple. So we take a tripod stand and we take the burner. And we take a beaker, in that we take the ice cubes. Fine. And we keep a thermometer attached and touching the ice cubes, and it is attached to the clamp stand. There's a stand to which it is attached. Fine. So this is the thermometer. Then this is ice. Then this is tripod stand. And this is the burner. Now what happens is, when we start to heat ice, what will happen? It will start to melt at 0 degrees Celsius. It will keep on melting. It will keep on melting. It will keep on melting. What is the important thing to note over here is that the temperature is not going to change until the entire ice is converted into the liquid water. Fine. So the temperature remains 0 degrees until the entire solid gets converted into the liquid state. Fine. Now you will say, ma'am, if at all the temperature is not increasing, then where is this energy, heat energy going when we are supplying continuously? We are continuously supplying the heat energy. We are heating the ice, it is getting converted into liquid, but then also the temperature is 0 degrees Celsius. Where is this energy going? This energy is basically used to break the force of attraction between the particles of the matter. Fine. So this heat energy is used to make the solid particles a little apart from each other, and then they convert into the liquid state. Clear, everyone? Yes or no? Is this thing clear
Yes,
to you
ma'am.
all?
Yes, ma'am.
Now, now because we are not able to see this energy being used up directly, we call this energy as latent heat. What does this word latent mean? This word latent means hidden. So this is known as the hidden energy, which is used to overcome the force of attraction. Clear, everyone?
Ma'am, I have a doubt.
Yes.
Ma'am,
Please
how
ask.
does heat help the um, mm, state of matter to convert into another? What does
From solid to liquid?
Yeah, ma'am, how does heat help in
When
that?
we heat any substance, the particles are very, very attracted to each other. In case of solids, if we talk, right? When we start to heat them, they start to get a little separated from each other. They start to acquire some kinetic energy. Slowly and gradually, they get
Ma'am,
converted
how
into
does
the.
the kinetic energy get acquired?
Sorry, how does
How
the.
does the kinetic energy get acquired?
So you must
Means
have
how
studied in physics that energy is a form which gets converted from one form to another. So in this case, the heat energy is getting converted into kinetic energy. That is why the particles are gaining kinetic energy and they are converting into one state from one state to another. Clear?
yeah.
Okay. So now we have the first new term for you all, which is latent heat of fusion. So first of all, you should know this word latent. It means hidden. Why hidden? Because we are not able to see that this energy is being used up, but then it is being used up. So what is latent heat of fusion? We are going to write the definition of this. It is very important. It is the amount of heat energy required to change or convert 1 kg of solid into liquid at atmospheric pressure. And one very important word I'm going to write over here, at atmospheric pressure at its melting point, because this happens at the 0 degree Celsius in case of ice. Clear, everyone? Any doubts? In what is latent heat of fusion? It is a very important question. Whenever you will have a test which will involve all these topics, maybe not this week, but in the next week, I will be giving you questions related to latent heat always. Fine, children? So understand it as carefully as you can. And in case you want to ask anything once again, I can explain you. And then there comes a question. The question is, why does the temperature remain constant? The temperature remain constant even if during the change of state, during the change of state from solid to liquid, from solid to liquid, even when continuous heat is supplied. Even when continuous. Who will tell me the answer of this question? I have just given the answer for this question.
Ma'am, me?
Yes, Sampath, you can.
Ma'am, because the heat energy which we are supplying is going and it is being utilized to separate the forces of attraction between the particles of matter.
Very good. Without increasing their kinetic energy. So we will write the answer. So answer for this is the heat energy supplied is used. The heat energy supplied is used in overcoming the force of attraction between the particles of solid during the change of state from solid to liquid without increasing see, the kinetic energy increases only when the solid have been converted into the liquid state, when the spaces are enough in between them that they are able to acquire some kinetic energy. Clear, everyone? Any doubts still here? The next term we have is the latent heat of vaporization. Same thing happens in the case of the conversion of liquid to gas. So that is the latent heat of vaporization. So what will be the latent heat of vaporization? Who can tell? It will be the heat required to convert
solids into liquids.
vaporization.
Ma'am, liquids
Liquids into
into
gases.
yes.
And how much liquid? 1 kg
1
again.
kg
That's
of liquid.
very, very, very important to mention the amount of liquid or solid. Fine. So it is the amount of,
Ma'am, why isn't 1 liter of liquid?
no, it is 1 kg only. We take out, instead of the volume, we take out the mass and then we put it using the densities formula. Though it will be same because the density of water is 1. Okay. But in
Okay.
case it is any other liquid, then in that case, the density might be different. So 1 kg might not be equal to 1 liter. But we take here the mass only, not the volume. So conversion of 1 kg of liquid into vapor at atmospheric pressure. Then tell me at which temperature it would be.
Ma'am,
At its
Ma'am, at the vaporization point, 100 degrees Celsius.
boiling point, right? At its boiling point is called latent heat of vaporization. Clear, children? Again, the same question is applicable here also, that what happens to the heat energy which we supply while conversion of liquid to gas. So what will
ma'am,
be the
will the
answer?
answer be similar to the one we answered before?
It won't be similar, it's the same. The only thing would be which will be different would be that it will be used to overcome the force of attraction between the particles of the liquid during the change of state from liquid to gas. Only the state will be different, rest the answer is absolutely same. Fine, shall I write or will it be clear?
Ma'am, it will be clear.
But I will write the question so that you guys know that you have to know the same thing here also. So what happens to the heat energy? This is the another way the question can be asked. What happens to the heat energy when we convert liquid to gas at its boiling point? So your answer remains the same, that it will be used to overcome the force of attraction. So what will be your answer? That it will be used to overcome the force of attraction. Clear, children?
Yes.
Okay. So at its boiling point. So answer is, it will be used to overcome force of attraction between liquid particles. Fine, children. Now there are two more very, very important questions. One after the other we are going to study. The first question is, why ice at 0 degree Celsius is more effective in cooling a substance than water at 0 degree Celsius. So why is it so that the ice is more effective in cooling compared to water at the same temperature? The reason for that is that the particles of water at 0 degree Celsius have more heat energy compared to the particles of ice. That is why which has more heat energy will not be able to cool as much as the one which has less heat energy. So ice is much more effective in cooling compared to water because it has more latent heat of fusion. Clear? I will write the answer for you all so that it is clear to you. Okay. Answer for this is, as the particles in water at 0 degree Celsius have more energy compared to particles in ice at the same temperature at 0 degree Celsius, since during the change of state from ice to water, heat energy is equal to latent heat of fusion has been absorbed. Because the water has more latent heat of fusion absorbed, that's why water is not as effective in cooling as compared to ice at 0 degree Celsius. Clear, children? Now a very similar question. It is, why steam is more effective. In fact, you must be knowing that in our everyday life also, if at all we are like cooking rice, we open the lid suddenly and the steam comes out, it can cause burns to us. Whereas compared to the boiling water, it doesn't, the burns are not as severe as in boiling water compared to in case of the steam. Why steam is more effective than boiling water for heating purposes? Who will tell me the answer for this? Think and answer. Who can tell me the answer for this? Nobody can tell? Why steam will be more effective for heating? What will it have? What will steam have compared to boiling water?
Ma'am, more energy.
What is this form of energy here?
Ma'am,
Latent?
latent heat of vaporization.
Yes. So steam at 100 degrees Celsius will have more latent heat of vaporization compared to the boiling water. So particles of steam at 100 degrees Celsius have more energy as compared to particles of water since during the change of state from water to steam, heat energy is equal to latent heat of vaporization has been absorbed. Latent heat of vaporization has been absorbed. Clear, children? Any doubts still here? Everyone is clear with this? Akshara, you are able to understand? Akshara, Sampath, your video is turned off. Are you all able to understand, children? Any doubts still here?
No, ma'am.
Okay. Next, very interesting thing I'm going to tell you, which probably is the last thing which I'm going to tell you for today after so many definitions. Children, now, what do you think? What will be the state of water if we say at 0 degrees Celsius? Think and tell me.
Ma'am, can you repeat?
What will be the state of matter of water at 0 degrees Celsius? State of matter of water at 0 degrees Celsius means at its melting point. What will be the state of matter? Will it be solid, liquid, gas, or what? No idea?
Ma'am,
Nobody
solid.
knows?
Ma'am, solid.
See, solid, surely it will be. But what did I tell? That when we start
Liquid.
heating the solid, it starts to get converting into the liquid state at 0 degrees Celsius.
Yes, ma'am.
But the temperature does not change until the entire solid is converted into the liquid state. The temperature remains constant. We wrote the question, why does the temperature remain constant? So it will be both solid and liquid at the melting point because the solid is being converted into the liquid state, and until the entire liquid is obtained, the temperature is not going to change. Similarly, at 100 degrees Celsius, what will be the temperature change? What will be the state of matter of water at its boiling point? Think and tell me now.
Both liquid and gas.
It will
Ma'am,
be
both
both
liquid and
liquid and
water vapor.
gas. Okay. Now, what about below 0 degrees Celsius?
It will be ice.
It will be only and
Solid.
only solid.
Solid.
Now, what about above 100 degrees Celsius?
Ma'am, gas.
It will be only gas because the entire liquid has already been converted into gas. What about between 0 degrees Celsius and 100 degrees Celsius?
Ma'am, liquid.
Liquid.
It will be liquid state. I hope this was all clear to you in at what temperature, what will be the states of matter, right?
Yes, ma'am.
So, okay, children, revise all these definitions and I'll see you all in the next class. Do revise and come in the next class. Fine, we will continue from here itself. Pranav and Rohit, are you writing something?
Ma'am, I'm
Done.
not writing.
Okay. So, can I log off now?
Ma'am, I had
Yes,
a doubt regarding the first part of the chapter.
Yes.
There's a question in the textbook saying that the smell of perfume, the smell
Is
of
matter.
perfume. Yes,
Is
ma'am.
matter or not? You have to tell. It is matter. Beta, because
Ma'am,
it has
is it
certain
because of
particles.
diffusion?
Yes, not diffusion. We are able to smell because of diffusion, but why we consider them as matter? Because if they do not have particles, then the smell would not have reached to us. So that's why it has particles, and if at all anything has particles, then it is definitely a matter. Fine.
Yes, ma'am.
Yes.
Okay. Thank you, everyone. Have a good day. Bye, everyone.